Okay, hey guys. We are making a video at the request of my students to do some more practice with operations with rational numbers. So get out your interactive notebook and let's first turn to our table of contents. So the last page that we put in was over standard 2.3, our number sense standard 2.3. Well, we are going to add to that. So page 19 for me could be something different from you. We're going to do more practice. These questions are level 3, number sense 2.3. Okay, so more practice with level 3 questions on number sense 2.3. And then turn to page 19. Here is the last page that we have on operations with rational numbers. Again, this was number sense 2.3. And so now we're going to do page 19. And you have this sheet, of course, you know where, on the activity table. I've already trimmed mine out to fit in my interactive notebook. I didn't do a perfectly straight job, but it barely fits in there. So I'm going to take what space I have at the top to write 2.3, of course, number sense, 2.3, operations with rational numbers. All right, so we have a total of 6 problems that we're going to work through down here. You don't necessarily need to separate with lines where these 6 problems are because, you know, you might need more room for some than others. I'm going to try to go ahead and like draw these lines just for a guideline. Okay? And if you have not already maximized your screen, you might do that now. Instead of watching this in the small viewer in the middle of your Chromebook screen, I would go ahead and maximize the video to take up the whole screen. All right. Now, I so desperately want to work these questions using an ink pen, but I'm going to be a good girl and I'm going to use a pencil just like you should. That way I can erase if I make a mistake. I'm going to rewrite this problem so I have more space to work it down. And it's going to start with negative 1.5 plus 3/4800 all times 2/5 times 10/16. So I do get to use a calculator, and I'll have that on standby when I'm ready for it. But the first thing is, you do know that the dot is the same thing as an x for multiplying. I'm going to do my parentheses first because order of operation, PEMDAS, tells us we work what's in the parentheses. When multiplying, I go straight across. But here, I can see that I can cross reduce. 5 and 10 reduces if I simplify by dividing by 5. 5 goes into 5 once, and 5 goes into 10 twice. I can also reduce 2 and 16 by 2. 2 goes into 2 once, 2 goes into 16 8 times. So this turns into 1 times 2 and 1 times 8. I could have further reduced this, but it just would have turned into a mess. But I can look at 2 eighths and reduce that by 2 and get 1/4. So all of this becomes 1/4. Write down the rest of the problem carefully because now we work with integers. You never know when just a sign of something can mess up. So what do I do next? Do I add these two values or do I multiply these values? You're right, I'm going to multiply these two values next. 3.48 times 1/4. Well, I could do it different ways. I could say this is like a number over 1 and say 3.48 is equal, times 1 is equal to 348, and 1 times 4 is 4. Or, and then I can divide that, or I could say 1/4 is 0.25, and then multiply it that way. Either way, I'm going to get the same answer. So, I could say 3.48 times 0.25, and here I would get 0.87. Or I could come over here and say 3.48 divided by 4 is 0.87. So it works either way. So this is now 0.87. I'll write the rest of my problem. Now I have negative 1.5 plus 87 cents. So like I've been saying, it's like I owe $1.50 library fee, but I only have 87 cents. Is my answer or my balance going to be positive or negative? Again, this is like $1.50. Since my negative is more, my answer is going to be negative. But I'll follow the A, B, C, D, E, big number on top, write down the signs, compare them and see that I need to subtract, and take the sign of the bigger number. And I'm going to get negative 63/100. You could have used your calculator, 1.5, and even though it says plus, I'm going to subtract 0.87 because my signs are different, and I subtract when signs are different. And I know I've got 63 and then taking the sign of the bigger number. So my answer here is 0.63. My answer is negative. Okay. So again, this is like an order of operations problem, only you had to deal with decimals and fractions. Problem number 2 is a complex fraction that we're going to simplify. And I'm going to start by putting ghost parentheses. Remember, I'm going to figure out all the top value, figure out all the bottom value, and then I can divide, because that's what a fraction line means. It means divide. So let's start at the top. I'm going to use my calculator, and I'm going to say 4 2/10 times 1 1/10 equals 4.62. And a positive times a positive stays positive. Looking at the bottom, my signs are different. So I'm going to subtract. I'll start with, say, $10.02, and I will subtract $8.42 and end up with 1.6. Aren't you thankful for a calculator? Keeping the sign of the bigger number, and this was also positive, all I have to do is now use my calculator, put in 4 62/100 divided by 1 6/10, and my answer is right here. Okay, so that problem was done simplifying a complex fraction just by using my ghost parentheses. Now, this is our opportunity to learn something new. I've already taught this in workshops, but you get to be reminded that any fraction with a denominator of 0, doesn't matter what the top number is undefined. So we're going to match these 3 problems with undefined, a positive answer, and a negative answer. So we need to find which one of those has a denominator of 0 and match it to undefined. Let's see. This doesn't even have a denominator. This denominator right now is -8. And this one, what is 5 minus 5? That's right, it's 0. 4 minus 7 is -3, and what's awesome is your calculators will figure that for you. Even though you're not allowed to have a negative, if I put in 4 minus 7, your calculator will say -3. Your negative might be on this other side, and it might be way over here. But as long as you're putting in whole numbers that are positive, 4 minus a positive 7, it will still give your answer. But -3 over 0, guys, is undefined. So now we just have to figure out which one of these is positive and which one is negative. Here, if I can remember, I'm going to come over to my margin, and I'm going to remind myself of my magic triangle when multiplying and dividing. So what is a negative divided by a negative? That's right. Negative divided by negative is positive. So this is a positive, but I have a negative on the outside. And what is a negative times a positive? That's right, a negative. So that one goes straight across. If you want to figure out, you should have known that 4/8 is 1/2, and since it's positive, keep the negative on the outside. You have 1/2, and then negative times a half is negative 1/2. Then let's look up here, 5 minus 7. Remember that trick I said about your calculator? 5, take away 7. If I'm taking away more than I have, yep, I end up with a negative 2. But a negative 3 times a negative 2? That's right. It's going to be a positive, and 3 times 2 is 6. That one was your positive. Okay, here is another complex fraction that I'm going to put my ghost zeros around. I'm going to figure out this value and the denominator's value separately. 1/5 times 1/3. Well, I can multiply straight across. 1 times 1 is 1, and 5 times 3 is 15. I did not have anything that I could simplify, so that just is straight across is 1/15. 5/3 minus 1. Well, I could do this two ways. I could say 5/3 minus the whole number 1. I can change that 1 into 3/3. So now my denominators are the same. And I can say 5 minus 3 is 2. And I can get that this is 2/3. However, I also could have said from 5/3 minus 1, I could have taken my calculator and said box topping 5/3, 5 divided by 3, I'm going to get 1.666. That's going to keep going. So I could just say 1 point repeating 6 minus 1. So 0.666666. It goes on forever. And I could have had 0.6666 divided by 1/15. I could have box topped 1/15 and did it all out. But it just turns into a mess with this. I like the 2/3 better. Okay? I could have said 1 divided by 15 is 0.06666. So I could have had this mess in my calculator. 0.666666 divided by 0.0666666. And I could have gotten this answer. What do you think that would be? Just 10, right? Let's look at this one. 2/3 divided by 1/15. Nice and clean. I just need to remember this can be written as 2/3 divided by 1/15, which when I multiply by the reciprocal, and that's how you divide fractions, is keep this the same, flip this into a multiplication, change this to its reciprocal. I could have reduced, cross-reduced, and 2 times 5 is 10, and 1 times 1 is 1. Both answers, 10/1, which is 10, or using my calculator, since I estimated it, I can get it down to 10. Either way, the answer there was 10. Now to our word problems. Here, I have a mystery product. This is pretty much only because I can't draw, and I did not know how to draw anything there, so I just put a bunch of question marks, said it was a mystery product, and this is an expensive mystery product. It costs $3.24 a pound, and then I have some pumpkins that are $4.50 each. So I'm going to go to the store, and I want 4 pumpkins. So if they're $4.50 each, you could do repeated addition and just do 450, 450, 450, and 450. But I'm just going to say 450 times 4, right? That's how much my pumpkins cost. And then I want 1/3 of a pound of this mystery product. So I'm going to add to that 1/3 of means times my 324-pound mystery product. So let's see here. 450 times 4, $18 for my pumpkins, plus 1/3, this means times, right? Number next to the parentheses, 324-pound, which is the same as like that. I'm going to do this step next. 1 times 324 is 324. 3 times 1 is 1. Oh, is 3. And 3.24 divided by 3 is $1.08. So the mystery product is going to cost me $1.08 plus, hey, my 4 pumpkins, 4 at $4.50 each, cost me another $18. So $1.08 plus 18 is $19.08. So $19.08 is my subtotal. I'm sure the store will charge me tax, and that will be my final total. Last question. I have 9.5 cups of flour in my house. I need to make cupcakes for a fundraiser, and each cupcake takes 1/4 of a cup to make. How many cupcakes can I bake? Well, I have 9.5 cups divided by each cupcake that will take 1/4. How many times will my 1/4 go into my 9.5? Visualize that. If each cupcake is going to take 1/4, I'm returning to my flour tin over and over again and taking out 1/4 each time. So how many times can my 1/4 amount go into my 9.5? Well, you can just say this is 9.5 and 1/4 is 1/4. That is the easiest way. And get 38. I could make 38 cupcakes. You could have also said 9.5 divided by 1/4, and then said 9 times 2, or 2 times 9 is 18, plus 1 is 19 over 2. Change that to times, flip this around, multiplying the reciprocal, simplified, and gotten 38 over 1, or 38. 2 ways to work that problem. All right, so I've taken these 6 problems and I've discussed them in depth. You should have a lot of good notes, even though it took me almost 20 minutes to do it. Anyway, good luck, guys, and you'll be glad you have these good examples.